So, in order to kind of dive into this chapter about bonding and putting things together, you already saw in your lab yesterday that we have to decide if it's a metal or a non-metal. And if there's a metal involved, usually we're talking about some sort of an ionic substance. And if there's only non-metals, then it's going to be covalent. So, we already got that down. So, the only thing I'd like to remind us of is that this hydrogen right here does belong with our non-metals. Okay, so that's the only thing that I'm going to fix right now. But the next part of naming and drawing things together is we have to look at valence electrons. So back in a previous chapter, we kind of went over how to recognize your valence electrons. So I just wanted to remind you on how to do that. Basically, you have your valence electrons right here where the A's are, but I can also show you how you're going to do it. With just the numbers of all your different groups. So everybody in group 1 is going to have one valence electron. Everyone in group 2 will have 2 valence electrons. So those are probably the easiest two. Then we go over to our other main group elements, which are over here in the P sublevel. And what we're going to see is that all of 13 have 3 valence electrons. All of 14 have 4 valence electrons. 15 have 5, 16 have 6, 17 have 7, and then 18 will have 8. So remember, the goal of bonding is that everyone is trying to have that octet or 8 valence electrons. So everybody's trying to get over to have the same electron configuration as a noble gas. Okay. Now, don't worry, we're not bringing back electron configuration, but really that ultimately is why things are bonding to begin with, right? So the next thing that we're going to be moving into, besides knowing how many valence electrons, is knowing when they're going to have a positive value for a charge. We're going to call it a charge. It's an oxidation state, and it's kind of what makes these things come together. And we're going to see that in a couple days. But for now, I do want you to take notes over this, that everyone in group 1, we only have one valence electron. Okay, so this is a little, let's see here. Let's just put a fake little element here. So we'll put, there is no element A. So we're just going to put, oops. We're going to put, yeah, we'll just leave it that way. All right. So we have A, and everybody in group 1 has one valence electron. Everyone in group 2 is going to have 2 valence electrons. Everyone in group 3, we already said, has 1, 2, 3 valence electrons. 4, we're going to see that we now have 4. So I'm going to stop there for a second, and this is going to be kind of our special little group right here, okay? Because at 4, if you notice, that is the halfway point between 0 and 8, right? So what that means is that he has 4 valence electrons that he can either choose to give away, or he can add 4 more to get the needed 8. Right? So we can add 4 more to it. So I'll switch my little pen to a red pen. Okay. So we can add 4 more valence electrons all the way around. Okay. Or we can take those original 4 away. Now, let me just erase those little red dots and let's continue talking about this. So once we've hit this little halfway mark, okay, now we're looking at, again, we have 5, so we're going to go ahead and draw in that 5th one. So you start doubling these up, just like with the bunk bed idea, where everybody gets their own space first, and then you start doubling them up. You're going to do the same thing with these valence electrons when you're drawing these little Lewis dot structures, okay? And that's going to be important for your drawing. So that one we're going to draw right there for 6. So now I'm right here, group 16, okay? We would draw it in the next available spot. Group 17, we would draw it here. And then a full octet would be shown like this, where we have 8 valence electrons total, okay? Now, with the charges, what we're looking at here is that when we have our made-up element and he only has 1 valence electron, what we're going to see is everybody on this side of the periodic table, mostly our metals, it's going to be easier for something to give that away, okay? So for example, something like lithium right here. It is easier for lithium to give one away and jump back an energy level to the helium electron configuration. It's easier for him to give it away. So therefore, if I give away an electron, right? If I give it away, I now have a higher proton number than I do electrons. So therefore, everybody in group 1, we're going to label with a positive 1. Group 2, it's going to be very similar. It's easier to give away 2 electrons, so he has a +2 charge. Everybody in group 13, until we get below the metalloids line, which we'll have a whole day to learn those, okay? But for now, something like boron and aluminum, we're going to go ahead and say have a +3 charge, okay? Once we get to 4, this is that in-between spot. So I'm going to go ahead and label this one as a plus or -4, meaning we usually don't put charges with these, okay? They're going to bond usually covalently, but we'll see how that evolves in this chapter. And then when we get to nitrogen or the group 15, now we're talking about something that had 5 valence electrons, right? So let me just show you that image real quick. So if I had 5, oops, should not have done it that way. Here we go. So if I show you 5 valence electrons, so 1, 2, 3, 4, 5, what we're looking at now is that it is easier to accept 3 electrons than it would be to try to get rid of 5. So what we're dealing with on this side of the periodic table is we are dealing with we need to find somebody who's going to give us 3 electrons. So you can kind of already see that, oh, maybe these can bond with something like boron or aluminum, right? Okay, so we have a -3 because we're only 3 away from being that noble gas status or octet rule is fulfilled. Something like oxygen family or the group 16, remember, that means now that we have that electron, we only need 2. So we're going to show that with a negative symbol. And these guys have a -2 charge. And then finally, group 17 is only 1 away. So we say a -1 charge. So make sure you have these written down. They're going to be useful in tomorrow's notes. And that way you'll be able to do that. Okay. But for today's notes, make sure you understand your group numbers are telling you the number of valence electrons. And when you draw them, you go around the dot. Or around the element. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So make sure you do that. That'll help with your drawings today.